lesson 6.6, we're going to talk about de Moivre's theorem. Okay, you can take a little glimpse at the right on what his theorem allows us to solve or figure out. The main idea behind it is that it deals with complex numbers and complex ideas. So we're going to review and talk about complex numbers a little more than we have in the past. So first we're going to talk about the complex plane. Basically, a complex number is written in the form a plus bi. A stands for the real part, bi stands for the imaginary part. Okay, a complex number accounts for every type of number we can have. Most numbers we talk about are real, but we can also have imaginary numbers. So if we're looking at the left, how we plot a complex number, we want to think of the x-axis as the real axis for complex numbers. The y-axis is our imaginary part. So if we're going to plot a complex number, we're going to plot the real part, which is represented by a, and then we're going to move in the imaginary axis, which is represented by bi. So at the right, if we were going to plot the point 2 plus 3i, 2 is our real part, so we go over 2. 3i is the imaginary part, so we would go up 3. So that would be our plotted point 2 plus 3i. The letter normally used to represent a complex number is z. If we want to find the absolute value, which is also called the modulus of a complex number, we are taking the square root of a squared plus b squared. Okay, so this represents the distance from the origin of that point. So in this case, if you look at the picture, that would be represented by r. If you look over here, we have some notation. B is equal to r times the sine of theta. If we use SOHCAHTOA and use our angle, we know the sine of theta is opposite over hypotenuse. B represents the imaginary part, which is the y-axis. So that would be equal to b over r. If we wanted to get b by itself, we can multiply r to both sides. So r times the sine of theta is equal to b. So that's where that notation comes from. We can use trig to represent complex numbers, so that's when they start, or why they introduce you to that other notation to represent the imaginary part. We can also use a similar idea for the a value, the real part, that's equal to r times the cosine of theta. So if we know what our a and b values are, and then we find the absolute value, or the modulus, which is represented by r, if we know those three values, then we can find that angle. We can write a complex number in trig form. Okay, if we think about that right triangle we were referring to earlier, cosine is going to refer to our real part, sine is going to refer to the imaginary part. So a few equations we should remember. We have a is equal to r cosine theta, b is equal to r sine theta, r is equal to the square root of a squared plus b squared, and tangent theta is equal to b divided by a. That r value represents the absolute value, or modulus, that we were talking about earlier, and theta is referred to the argument of z. In this example, we want to find the trig form with theta between 0 and 2 pi for the complex number 1 plus radical 3i. The first thing we should do is find the r value, which is the modulus, or the absolute value. So we're going to take the absolute value of 1 plus radical 3, which is equal to the square root of 1 squared plus radical 3 squared. 1 squared is 1, radical 3 squared is 2, so 1 plus 3 is 4, and you know the square root of 4 is 2. So the r value is equal to 2. Next thing we need to do is find theta, or the argument. Theta is going to be equal to the inverse tangent of b over a. Our b value is radical 3 over 1, which is our a value. using your unit circle, you know that it's theta value of pi over 3. So now using that trig form above, we know that z, our complex number, will be equal to our r value, which is 2, times the cosine of theta, which is pi over 3, plus I times the sine of pi over 3. So this is our complex number written in trig form. Next, we're going to look at the products and quotients of complex numbers. So if we have z sub 1 and z sub 2, if we're going to multiply those to find the product, we multiply our r values together, the modulus, and then we add the theta values together for each, the cosine and the sine. If we're dividing these two complex numbers, we're dividing the r values, the absolute values, and subtracting the theta values. In the example below, we want to express the product of z sub 1 and z sub 2 in standard form. So we're going to use the formula in step 1 above. We need to multiply the r values together. So we're taking 4 times radical 2. And then inside our brackets, we have the cosine of pi over 4 plus pi over 6. And then we're adding to that I times the sine of pi over 4 plus pi over 6. Next, we would have to find a common denominator for pi over 4 plus pi over 6. If we do that and simplify, we get 4 radical 2 times the quantity cosine of 5 pi over 12 plus I times the sine of 5 pi over 12. The next step of simplifying, we would get 4 times radical 2 times the quantity of the cosine of 5 pi over 12 is approximately 0.259 plus the sine of 5 pi over 12 is approximately 0.966. So our final answer is approximately 1.464 plus 5.464 times I. The last thing we're going to do is discuss de Moivre's theorem. So if we have a complex number and we're raising it to a positive integer, then we have this formula below that we can use. So if we take the complex number, what we're essentially doing is raising the modulus, or the absolute value r, raising that to the same degree, and then we're going to multiply that degree of n by each of the theta values for cosine and sine. So if we take a look at an example, suppose we have the complex number z equals 2 times the cosine of pi over 4 plus I times the sine of pi over 4. Suppose we want to take that z value, that complex number, and cube it. So we're going to cube that whole thing. And then using that formula, that means we're going to cube the r value and multiply our theta values by 3. So we're taking 2 cubed times the cosine of 3 pi over 4 plus I times the sine of 3 pi over 4. If we do some simplifying, we get z cubed is equal to 8 times the cosine of 3 pi over 4 is negative radical 2 over 2. The sine of 3 pi over 4 is radical 2 over 2. And if we simplify this, we get z cubed is equal to negative 4 radical 2 plus I times 4 radical 2. So we can use de Moivre's theorem in order to simplify complex numbers that are raised to a power.